Hello guys, Matthew here, and this is Blender. If you don't know, when I had free time I was a 3D animator for my main channel, Crystallized Entertainment. And this is my asset library filled with props and scenery textures. This is what I did as part of a secret project I am still undertaking, and represents 1.5 years of hard work. And there isn't a backup of it. Today I'm showing you how I rectified this and built a new file server / NAS to provide an on-site backup of my files. First, a bit of context. In 2016 to 2018, I had a 2001 Power Mac G4 workstation that I called the Omega server. It had a 160GB Maxtor drive, limited to 128GB due to the IDE controller. But the G4 ended up failing first as one morning it wouldn't boot up. I'm assuming being kept where it was provided little ventilation, killing the power supply. I did buy a replacement G4 in 2020 for parts, but I never got around of salvaging the PSU. So for the last 4 to 5 years, I've had no backup solution in case of my Elements drive failing other than restoring from my previous Elements drive, which could be 4+ years out of date. Obviously this isn't ideal, so I'm hoping to keep more up-to-date copies of my projects that would be devastating if I lost it. Since I was on a tight budget, I did compromise on a few things to bring the cost down. Let's start with the motherboard. I went with a 4GB variant of the Raspberry Pi 4. I didn't spring for the 8GB Pi as I felt it wasn't necessary for the roles I hoped to fill, and so the 4GB was more than enough for what I needed. I also grabbed a 32GB SanDisk microSD card, which will act as the boot media for the server. I realised I shouldn't have the boot media on a single drive in event of it failing, but with an image with all the settings in place, it isn't a huge issue if the microSD card does fail. For the main storage media, I chose the Seagate 4TB NAS hard drives. In the past, I haven't had the best of luck with Seagate drives, but with equivalent Western Digital drives being too expensive, I decided to give them another shot. Interestingly, the price has lowered since I have bought them. £42 from £84. These drives were built exactly 1 year apart, with one dating from May 2013 and the other being from May 2014, and seems to predate Seagate's Iron Wolf branding for their NAS drives. I'm aware I am risking my data with such old drives, but I'm hoping they still have a few years left in them. And finally, the case. The natural choice was the Argon Eon, specifically designed for NAS/file store operations, and an attractive triangular design. It was a no-brainer of a choice for me. All in all, the entire build cost me £325. I think it's pretty cheap for a NAS with all the capabilities it potentially has. I'm going to time-lapse the build process as it is a fairly straightforward process to construct the NAS. In fact, I would say this has been the most painless computer build I have ever done, and that's including setting up the software. Coming up in this time-lapse, I will slow down just for a moment as I want to show that the SATA backplane, for whatever reason, also has a pass-through for a USB 3 port, seemingly for USB sticks or whatnot. Kinda strange to be honest. Throughout this build, I either kept finding things I missed in the box, or what the included screwdriver can do. Like, this is a high quality screwdriver, with proper magnets and even can screw in motherboard standoffs. This is something I would expect costs a pretty penny for itself. Overall, I think it's pretty attractive when it's all assembled. So let's move on to the software. So first things first, the operating system. Most people I've seen using this case have chose Open Media Vault. Me, I wanted a desktop interface on my server, so I chose the bog standard Raspberry Pi OS to download. The official SD Imager app the Foundation provides has quite a few hoops to jump through to work in Linux, so I just elected to image the microSD through Gnome's built-in disk tool. From there I did the first boot of my server with a mouse and keyboard plugged in and went through the first time setup. Since this is a server, it made sense to have the user account named simply Administrator. The Ethernet initially didn't work, but plugging it into a different port on the switch quickly solved that issue. Now that we're on the desktop, the first thing I did was to go into the Pi settings and enable VNC connections. Also taking the opportunity to rename the server, officially christening her as the Storebox, which is what I will be referring to her for the rest of the video. A quick restart and I now can connect from my workstation, so I no longer need the keyboard and mouse. Next thing is that I installed the Argon scripts to allow the OLED panel on the case to work as intended. Now there's a few things that we'll need for a web interface if I don't want to mess around with terminal commands, which I didn't. The interface of choice was Webmin. It works with a desktop environment warning compared to OpenMediaVault. Installing it was fairly painless. I copied some commands from the website and posted it into the terminal, and I'm off to the races laughing. Now that that's all out of the way, it's time to set up the RAID configuration for the drives. By default, Linux doesn't support software RAID over USB, and to bypass that, I simply installed Madam through the terminal. Now I can fire up Webmin and graphically configure the RAID. Fortunately, since I'm configuring it on the base machine, I don't need to put the IP address into the web bar. Simply typing localhost along with the correct port of 10,000 loads the logon screen. Typing in the username and password I set on the base system grants me access to the interface. To save time, I just typed in RAID into the search bar to quickly get to the settings I want. Since I got 2 drives, I chose RAID 1, which offers redundancy. It's kinda like shadow copying the entire contents of one drive to another. It doesn't have any performance benefits, however the peace of mind knowing if a drive fails so I don't lose what I have backed up is well worth the cost in my opinion. I told the store box to skip initialization of the drives and the RAID itself, as I don't have the days that would take. Once the RAID definition is set, I fired up GNOME Disk I installed ahead of time and did a quick format to ext4. I struggled to come up with a name for the drive for the longest time. I know I should have used ZFS instead of RAID, especially with these high capacity drives with this better reliability, doesn't suffer from the white hole, and better, and maybe even quicker, chance of rebuilding the array in event of a drive failure. But considering this is the first time I'm commissioning a server, I went with something relatively straightforward. Next up is the part I've been drilling the most, Samba. Now, me and Samba aren't exactly on talking terms, as I have never been able to set it up on any machines. The terminal commands I could never get to grips with, and I never was able to make the Elements drive shareable, which has hampered my ability to transfer data across my machines over the years. I have had mild success with the MacBook when it briefly ran Fedora KDE, but it was buggy at best. It's strange, with all the advancements Linux has made over the years and years of use, no one has figured out how to create a GUI to configure Samba. But that's in the past. Let's get back to the present. Like with RAID, I wasn't sure where it was being kept in the web UI, so I elected just to type in Samba in the search bar. Webmin says I don't have Samba installed and directs me where to install it. It was pretty painless as Webmin grabbed all the necessary packages and it just installed it. Literally 3 mouse clicks later and Samba was ready for configuration. Now, how I configure Samba is going to be a bit sporadic as I'm going to have to go through some of the brick walls I faced in the 4 hours it took me. The first thing I did was creating a share to the RAID drive. This was a pretty straightforward process, as a few clicks here and there, and copying the path of the drive to paste into the dialog box, and that share was ready to go. The users is something I struggled with, as I hoped to get away without needing to create any actual users. This obviously isn't how you set up Samba, or at the very least through Webmin. How it is done is that you go through user synchronization, and I enabled the following settings. Most would recommend enabling all of them. However, I wanted to manually delete the users even if the actual account is gone. Once that is done, I went to convert users and add Matthew with all the correct permissions and a password. I didn't want to use the administrator account if I could help it, as that is bad practice. With all the users set, I go back to the share and add them to the accepted users and make sure the share is writable. This all in all took 30-ish minutes. Now back to my main workstation to check if I have successfully wrangled with Samba. And... oh. Once again, the tension between me and Samba wielded its ugly head. And this is where the aforementioned sporadic quickfire comes from with the troubleshooting. First off, not having access to the RAID drive. This is a little convoluted as this can be caused by many things. I am not exaggerating when I say I spent an hour to an hour and a half tackling this problem. During this time, I discovered the issue is that the Matthew account doesn't have access to read or write to the main storage drive. I tried different suggestions online, including editing the permissions in Webmin to give me access. In the end, I yield, and I've been forced to use the main administrator account to gain access to the drive. As a side note, the only reason I discovered this was the problem was because I brought in my 2010 MacBook to see if the problem was just exclusive to New Octane, which just hanged when I put in my credentials. macOS, on the other hand, was far more useful and gave me a meaningful error to help narrow down the cause. Now with it all set up, I can now skin it. This is the only reason I went with Raspberry Pi OS and VNC instead of the more sensible dedicated NAS operating system. What I chose to skin the server to was Windows Server 2003, with the link to Webmin skinned to look like the management console found in RM's third release of the Community Connect package. I am very happy how it turned out. It looks better than I hoped it would. I recreated this icon during one D&D session from a screenshot of the Community Connect 3 desktop. Now the real moment you've been waiting for. Performance. I copied the folder I planned to back up, which is over 100 gigabytes worth of data, and performance was rather lackluster. At the time I couldn't figure out what was causing the slow speed. It could have been the old 5900 RPM drives, it could be a bottleneck with a USB over the network on both ends, etc. But it turns out the problem was my antiquated infrastructure in my room. The network switch is the Netgear FS116, which only does 100 megabit Ethernet. I've been using this switch for about 3ish years, but the switch itself, or at least the model, is pushing 20 years. Turns out 100 megabit equates to about 10 megabytes per second. I have bought an 8-port, 1 gigabit switch as a patchwork solution which has increased the speed, but I plan to properly upgrade my infrastructure to support 2.5 gigabit as a future project. Since I only can find 8-port switches at those speeds, I bought the aforementioned gigabit switch so I don't end up with more cables than ports as I inevitably incorporate more equipment into my setup. And you'd think this would be it for this video. The server is all set up and I have backed up my files. But there is one more thing I want to talk about. This is my Plex server. It is also hosted on my workstation. It houses my movies, shows and downloads of YouTube videos in the event of the actual content disappearing from YouTube, which happens far more often than you think with me. But because it's on New Octane, I need to have it on when I want to watch something from Plex on my TV. But with the cost of living crisis, there has been a strong deterrent not to do that. With the commissioning of the store box, I could transfer my Plex over and use that instead with its superior power consumption. Originally, I just planned to install Plex and transfer my library over with the help of this Reddit thread. But a month or two before I built the server, I got introduced to an alternative called Jellyfin. After learning it was free and open source from Linus Tech Tips, I quickly decided to take advantage of the opportunity and jump ship. So, firing up the terminal, I installed the app to transport HTTPS and LSP release packages. Now that those packages are installed, I copied and pasted a curl command from the guide and added a repo to the list Raspberry Pi OS uses. From there, I used apt update for the OS to be aware of this addition and installed Jellyfin like any other application that I would install via the terminal. I can use a GUI from here on out. Type in the server's IP address and the port 1896 fires the web interface up. The initial setup was easy enough. However, like Plex on New Octane, when I initially set that up, Jellyfin couldn't access my data drive. To fix this, I need to jump back into the terminal and type in the following command you see on screen, and this solved the issue. From there, I just added all of my media library, making sure it uses the same naming conventions as Plex uses, and then leave the server to scan through all the media. I also took advantage of this process and created an icon that points to the server settings. Now onto performance. Due to the fact what I tested is a copyrighted TV show that is still being aired, I won't be showing it on screen. However, we can take a look at what the server was doing. When running the show without any transcoding, as expected it didn't eat up a lot of CPU, but trying to transcode it at 480p 3 megabits per second, it just maxes the processor out and it constantly buffers on the client's end. Since the only machine I own that would need transcoding is the 2010 MacBook, it's not so much of an issue. I know this would be alleviated if the Pi had some sort of GPU acceleration to offload the transcode, but alas, here we are. So in conclusion, while we can all agree the varying choices I made throughout the build is very much bad practice in the IT industry, this file server has turned out great for a low budget, moderate capacity local backup solution. Plus, it has the added benefit of me being able to access things like my recipes on my MacBook without needing to jump through any hoops. It acts as a great midway point between the machines, in addition to being a backup server, and all at a fraction of the size of the Power Mac that preceded the store box. Thank you so very much for watching this video, and I hope you enjoyed it. Peace.